So before I start, let me ask you a simple question. So did you get the idea of what is the role of Kafka or any queue in an organization? Did you get the clarity? Why do we need Kafka or queue in an organization? All right. So we recently have got one project from somewhere in UAE. It's still in the pipeline, and their entire workflow that they want the messaging system is actually something that can be done with Kafka. Okay, any messaging queue. All right. So we're going to go over the Kafka and going to figure out how does it work. And then we are going to do the streaming over Kafka. And after this, we are going to start with data frames. All right. And after data frames, we will continue with GraphX and the other two components. All right. So this is a very important topic. And other than Hitendra and Robin, uh, is everybody else also clear about the role of a queue in an organization? All right. All right. Let's say there is a topic on which there are too many messages coming. Let's say there is a topic on which there are too many messages coming, and what you want to do is you want to process those messages in a load balanced manner, meaning some of the messages of that topic are processed by one machine, some another machine, and so on. What do you do? Is it possible? Is it possible to divide messages between on a topic amongst the consumers? Yes? How? That's right, by creating consumer group. All the people who are in the same group, they will get parts of the messages. All right. The messages will be distributed amongst the members of the group. All right. Now, if let's say, so in general, whenever the two unique consumer groups or two different consumer groups will get all the messages of a particular topic. If so, if there are, let's say, 50 messages coming here, producer 3 produced 50 messages, consumer 4 will get 50 messages. Okay, while consumer 2 and consumer 3 will divide amongst themselves, and approximately it will be 25-25. Okay, so consumer 2 and consumer 3 will not have the visibility of all the messages, while some part goes to 2, some part goes to 3. All right. Now, another question that people ask in when they're asking you about the queue, that what happens when let's say a consumer process that is consuming the data from topic, let's say consumer 4, intermittently dies. Okay, what happens then? Let's say consumer 4 died for an hour. Okay, consumer 4 died for an hour and comes back after an hour. What will happen to the messages that have been emitted during that 1 hour? Okay, What will happen to the messages? Let's say consumer 4 was there, and between say 4 to 5, consumer 4 was shut down. At 5 o'clock, you realize, oh, the consumer process is down. You restarted it. What will happen to the messages from 4 to 5? So basically, the Kafka cluster gives you the luxury of started reading the data from the beginning of the topic, and the messages remain in a topic for 24 hours. Messages in a topic remain there for 24 hours, and they expire after 24 hours. All right. So now question is that how do I ensure that I don't, when consumer 4 comes up, I only get the messages from 4 to 5, not since last 24 hours. Okay. The idea is that you consume the messages and then you delete the messages. And once you delete the message, then that means you have successfully committed. So from your view, the message is removed. All right. For the other consumer, that message would remain. So for you, the message is gone if you delete it. All right. So the general thumb rule is that each process consumes a message. When they have successfully consumed a message, they're supposed to inform Kafka that, hey, we are done with consuming this message. Please delete it. Deletion does not mean that the message will not be visible to other consumer groups. It only means that this message is gone for the current consumer. All right. If you don't delete it, the message will come back to life after some time. Okay. If you don't delete it, the message will come back to life after some time. That means that in case you could not consume a message while you read the message from the queue, but you shut down in between, then if you restart the process, that message which was not deleted will also be available to you. All right. So those are the nitty-gritties, and way, that way, you will be able to have multiple processes consuming data from the Kafka queue. All right. So a question from Mohammed is, using consumer group, is the division implicit? Yes. Division is done by Kafka. Okay. Just that consumer has to tell the name. Okay. All right. Question from Raju is, will there be separate channel for each consumer or consumer group? I hope you got that. Uh, right. So yes. A question from Sachin is, so we can create as much topic as required. Okay. As required by your business processes, you can create those many topics. And you speak on topics. Okay. So generally in an organization, there could be say 100 topics or 200 topics, but the messages in each topic could go into millions. All right. So topics are relatively static. And when you're speaking, let's say producer will produce messages on a topic. Consumer will consume a message from a topic. Topic is like a pipe. Okay. Topic is like a pipe on which the producer speaks and consumers consume. Yes. And topic is used for broadcast. All right. Let's do some hands-on with Kafka. All right, let's just pull out the discussion we had last time. Okay, so Let's just take a look at what it means. So first of all, I'm going to walk you over this particular script. Okay, let me zoom it out. So can you see the screen? What's the date today? Today is 5th May. Okay, so yes, I'll just put PDHS. Great, great. So let's walk through this script one at a time. Here we are mentioning path. What does it mean? When we type a command on Unix console, the Unix console look into the path and look into the meaning of that particular command in these directories. When we say ls on the console and press enter, the Unix shell is going to go through the path variable and figure out where is the ls file or where is the ls command. All right, so path helps Unix shell discover the command and the order in which it has to find. It starts from left to right. The values of path are separated by colon. So here we are saying that export path means we are setting this path variable equal to whatever it was earlier, colon this. Okay, meaning to the list in which it will discover the command, we are appending a particular path directory. All right. Dollar refers to, so when we are defining a variable, that time we don't have to specify dollar, but when we are referring to a particular variable in the environment, these are called environment variables. Path is a special environment variable in which the Unix shell looks into for figuring out the meaning of a command. Okay. So here we're saying that whatever was the path earlier, append this to that path. If you execute this command twice, then this will be appended. This will be appended to the path twice. All right. So let me get started and open the console as well. All right. So let me just get started. Now I'm logging into my account from the terminal. All right. All right. So this is what I'm saying. Export path, and I'm setting this. To know the status of current variable, we could just say echo path, and it'll show us that this has been appended. Okay. If we run the previous command twice, then this path will be appended twice. Okay. And when we run any command, either we could give the absolute path of this command. Okay, so here, when you look at this particular command, where is it located? This is located inside this folder. Either we could have executed this command Kafka topics using this absolute path, or we add this path into the directories, okay, and so that it would discover it there. So here we are saying Kafka-topics.sh. Okay, so we are creating a topic test. Let's see if it works. It says test already exists. Okay, so we are going to say 5th May. Okay, so test is 5th May 2018. All right. You can, if you want, you can create your own test. And okay. Also, generally, we should create this with your login name so that you should not, so that you are able to recognize another person does not write to your Kafka queue. Okay, Kafka topic. So now we can quickly take a look at. Okay. Also, before I jump to next command, let me explain to you this command. This Kafka topics.sh is located in this directory, Kafka broker bin. This command is your the driver, or you can say Kafka command with which you can interact with Kafka brokers. Here we are saying dash dash create. We are telling that to create a topic. Create a topic. Here we are saying this is the name of the topic. Here we are saying partitions equals 1. Therefore, it is not going to be sharded and distributed amongst multiple brokers. Replication factor is 1, meaning the messages pushed to this topic will not have many copies of it. Many copies are generally useful when you want this topic to be consumed in load balanced manner. Now here is another important part. Here we're telling Kafka that, hey, here is the zookeeper location. So we are telling Kafka topics that find out about other Kafka brokers using this zookeeper, and that way or find out the Kafka brokers or broker to interact with any of them using this location in Zookeeper, because all of the brokers are writing their names in Zookeeper. Therefore, to find out about which brokers are functioning in the network, the most correct way of doing that is using the Zookeeper. All right. Again, to take a look at what is the list of Kafka topics, we could always say Kafka topic dash dash list. Okay. So let's take a look at.
Sandeep, we are using Zookeeper just to register in the Zookeeper that we are going to use this topic.
Okay. Just let me change the speaker because it's coming from my laptop. Okay. Can you repeat what you said?
Yeah,
Because
why we use Zookeeper? Zookeeper is you use just to register in Zookeeper that we are using this topic.
right. So see, it's like this. If let's say you had a school, right? In the school, you had like multiple sections: section A, section B, section C. And all the sections monitor names, if you have to find out, there has to be a central place like principal's room, in which every monitor could go there and write their name that they are the monitor for today, right? In the same way, all the brokers, so that brokers can find out about each other, they go to the principal's room, that is the zookeeper, and they write their name there. Okay.
Okay.
Um,
Yeah,
did,
so
did, did I make sense?
Zookeeper responsibility is to finally display the topics which are registered.
Yes. So not only topics, brokers. Okay, let me repeat what I said.
Do you mean
So
Kafka brokers?
right. So whenever you have many processes, right? Many processes. Okay, the whole ecosystem of Hadoop registers themselves in Zookeeper. So Zookeeper is like this. Okay. Process one is, let's say this is one Kafka broker, KB, I'm writing the name, KB1, running on some computer. They'll go to Zookeeper and write their name. Who is a broker? Broker is a process that is the main worker of Kafka. Okay. Then you have another broker on second machine. Okay, they will also write their name in Zookeeper. Then there could be a third machine on which you are running the third broker of Kafka. They will all go and write their name in Zookeeper. So you can see Zookeeper client. If you interact with Zookeeper, you will find out that if you go into, say, ls ls/brokers, right? So you can see broker/IDs here. Okay. So here you can see there are four brokers listed. All right. There are four brokers listed, and to know about any of these brokers, you could always say get me, say 0. So it shows us the information about each of the brokers. Okay, it shows that this is the IP address of the machine on which one of the brokers is running, and here. So they all of these brokers have written their name inside slash brokers. Okay, slash brokers slash IDs, and say 0. This one has written its name as 0. This one has written 1. This one has written 4. That's what it has done here. And you can always find out about brokers using this. Okay. And brokers is nothing but programs, softwares running at a particular port. And that's what they're informing here, that, hey, I'm running at this particular port, and so on. All right. Did I make sense, Sachin?
Yeah. So all these are Kafka brokers.
Yes, yes. And what does Kafka brokers do? Kafka brokers are the servers, broker servers, Kafka servers, which are doing the main work.
Okay. With to whom Kafka client is interacted.
Yes, yes. All right.
Okay. Thanks.
Okay, great. Now, next question. Let me just go over the questions. I kind of missed the questions. All right. There are quite a few questions. Let me just increase the chat window size. Wonderful. So, all right. A question from Vintav is that it says topic exists. Okay, probably you need to create another topic because I've already created the topic. There cannot be duplicate topics. There will be only one topic. All right, thank you, Raju. Can we say multiple instance of Kafka is broker running in multiple machines? Yes. Okay. So basically, broker is the only server that Kafka has. There's no master slave. Kafka uses Zookeeper as the master. All right. Now, a question from Robin is, I created my own topic, but I still encounter error for zookeeper-create. All right. So if you have created once, then you can't create it again. That could be another problem. Okay. So let me check if that topic is already created. Okay. So we had this, and we could do grab pipe. Oh, it's not yet created. What kind of error are you getting? Tech K TECH TECH. I see. I see. Could you try once more? Which node are you on? Are you on F or something like that? Oh, you're getting the Kafka topic.sh is not found. Did you export the variable properly? Okay. Please share your screen. All right. So we have here. Okay, go ahead. Command not found. Okay. Okay, okay. So, all right, probably what I will do is I'll also log in into F. All right, so let me just go to user HDP and current and Kafka broker. All right. So I'm also trying the same thing with U on F. Kafka, what is that command? Kafka dash topics. All right. I'm just wondering why this is not there. Can you just use the absolute path, as in slash user slash HTTP? Oh, you said CURREMT, not ENT. Oh, there is a mistake in current. Slash HTTP slash current. All right. Yes. Now try again. Great. Great. All right. All right. Great. So I created my own topic, but I still encounter this error. Okay, this is done. Now, question from Alok is, what is Kafka client? This is Kafka client, essentially. This is basically a command called Kafka topic. And this Kafka topics is essentially one of the commands with which you can talk to it. We'll talk about a couple of more commands in this folder. There are some more commands like this one we don't require the first one to start the server and stop the server because that's happening already. And here there are some more commands like there is console consumer, console producer, and so on. All right. So that we are going to talk about soon. A question from Bintao is that Zookeeper localhost 2181, can I use another local host here? Anywhere you have Zookeeper installed, that those locations you can give. Also, you can give the locations of the Zookeeper in the form of comma separated list. Okay, so these URLs of the host could be comma separated. In case one host does not work, it will try to fetch the data from, it will try to fetch the list of brokers from another Zookeeper. Okay, so a question from Robin is, okay, do I need to set my own port? Not really, not really. This is, here we are not creating a service. Here we are just talking to an existing service. And a question from Prashant is that not sure if this question is already covered, but is it true that Kafka getting replaced by some other technologies and losing its ground? That I'm not sure, but I understand that Kafka is very prominent and is not being replaced much. But even if it does, the philosophy of Kafka will remain as such. You'll be amazed to know that the philosophy of Kafka and Amazon SQS is very much similar. Okay, so whatever we learn about Kafka is also applicable to, say, Amazon SQS, which is a hosted queue that you could use. All right, great. And question from Bintao is, where can I find more where can I find or check more Zookeeper localhost? Okay. All right. And yeah. So AWS Kinesis was there. I just forgot what is it. Let me take a look. Yeah. I think this is the one that's replacing Amazon SQS. Okay. I think this one is the one that is the replacement of Amazon SQS. Yes. All right, a question from Abida is where can I find more Zookeeper? You can generally take a look here. So Zookeepers are generally listed here. You can see these are the all hosts that are running Zookeeper. This I'm seeing in Ambari. All right, and even Kafka brokers, I see. You can see here the Kafka brokers are stopped on these hosts, so we can start the Kafka brokers. All right, in case some of the Kafka brokers are down for whatever reasons.
Hi Sandeep.
Yes.
So Sandeep, this AWS Kinesis will replace the this Kafka, or it is looks like same as a Kafka.
Yeah. So, a good question, Alok. So basically, there used to be Amazon SQS, which was very similar to what Kafka is. Amazon SQS was, I think, renamed to Amazon Kinesis. Okay.
SQS.
The difference is that the Kafka is for your own private cloud, while or your own cloud, while you don't have a control over Amazon SQS or Amazon Kinesis. All
Oh,
right, because you can't start a service, you can't stop a service. You can only you will be charged by Amazon for the load. Okay.
so they are not giving like a open source. You can download and install and do like that.
No.
Okay, okay. So you have to depend on AWS. All the
Yes,
things.
yes,
You
yes,
just write the API. You can get the SDK and you can do that.
yes. You push the message, read the message.
Okay, 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 sir.
Okay. Question from Prasant is why they are called brokers. Interesting question. Brokers is they are basically message brokers. You remember that earlier there was something called the terminology brokers is comes from Korba kinds where long back, and they are message brokers basically. Okay, they trade message, they transfer message, and then they receive message and give message, right? They don't produce message, they transfer message from here to there. That's what brokers do. Correct. A question from Vidya is where can I find more Zookeeper localhosts such as 2181? So basically on almost all of the hosts in our cluster, we have set up the hosts. You can always find these in the Hue, sorry, not Hue, Ambari. You go here and take a look at Zookeeper clients. There you will be able to see Zookeeper is installed on all machines. All right, Vinta. So you can click on Zookeeper here and find out their IP addresses. Yeah, you can see. You can click on any of them and find out about the host name. Okay, so just to check, if you let's say this is which host, I don't know, and let's say I'm on this and I am here and I'm saying Zookeeper. Okay, Zookeeper, and I'm putting this host and 2181. All right, let me just see list. So you can see I can use any of these IP addresses. So you can find the IP addresses from Ambari and then use that. Okay, a question from Binta is where does 2181 come from? Good question. So this we have already, this is something that we already know. At the time of Zookeeper, we talked about the Zookeeper runs on the port 2181 in general. Okay, 2181 whenever we have, say, Zookeeper here. So Zookeeper server, if you take a look at this and go to, say, Zookeeper here, you'll find out the port number here. can see it is 2181. All right. So that way you can find out about the cluster. Great. So let's move on. Great set of questions. So we were able to create our own topic. This I'm doing it because this will not only help you understand streaming, but will also help in understanding of Kafka. Okay. So now the next thing is we need to talk to a particular Kafka broker. Okay. So we are going to first find out what whether there is a broker or not. Okay. Whether there is a broker or not at this port localhost. Ideally, it should be there on all the machines, but sometimes it is not there. Okay, so just now we started Kafka on almost all the hosts. So let me just take a look at Zookeeper. Had Zookeeper been informed or not? Right. So brokers and IDs. All right. I see. It is still 0, 1, and 4 and 5. Okay, it is still 0, 1, and 4 and 5. So I'm going to, this is my E, this is my F. Okay, so I'll just pick one of the hosts here. All right, how did I reach here? I started Zookeeper client. Okay, here I started Zookeeper client, and then followed by I typed ls/brokers/IDs, and this is what I did. And then I'm doing brokers/IDs. Pick the one from there. So I just picked the 0, and from there I figured out the IP address of one of the brokers. I could even pick 4 or 5 or whichever I want. Okay. So let me just get started. So this is the important part where we are discovering about the brokers. All right. We are discovering about the brokers. Instead of this command is not doing this job for us to find out about the brokers automatically. Therefore, we have to find out about the brokers by talking to Zookeeper, right? We had to go to the principal's room to find out about the various monitors in our school. All right, or various class teachers in the school. All right, so that's what we're doing here.
Sandeep, the command which you have just pasted, give the broker list. Just pasted. Zookeeper IP.
Yes, this one. So first you launch the Zookeeper client, then you type this ls/broker/IDs. Then you pick one of the IDs, okay, and mention that instead of 0 here, whatever ID is like 4, 5, or 1, okay. And from there you find out the IPs, okay. From there you find out the IPs, okay. Find the IP. So that's what we did here. We found the IP. Okay, this is the IP address of the broker. So instead of this, we could say this. All right, and we could start after exiting from the Zookeeper console. We could start producing. On this topic. I again shifted back. I'll turn off the second terminal because that's causing a bit of confusion. All right, so here we have created the producer. All right, so on one end we have created the producer. We could also open another terminal and start consuming the messages. Okay, I'm opening another terminal.
Sandeep, one question here.
Yes.
So like when we create the topic and there are multiple broker is there. So when we create the topic, so topic will be present all the broker or only particular broker itself?
All the brokers.
Okay, like first we create the topic and then we choose one broker out of 3, 4.
Yes.
So that topic will be present all the brokers. It is not necessary I have to give the particular broker itself.
Yes, you are
Oh,
right, and a very good question. This is something I should have clarified. So you can pick any broker. That when we create topic, the topic gets communicated to all the brokers, and all the brokers know that there is a topic of this name. So we can talk to any broker and start producing messages such that all the brokers you can produce to any broker and you can consume from any broker. So in this diagram, the one that I was showing you here, one user could produce here and consume from here.
okay. So
Okay,
automatically it will be all the broker get that topic.
that's right.
Okay.
Or not only on the topic but also messages. Okay, also messages. All right.
So it means like number of broker is equal to number of partition like that, or partition is something different.
Right, you're right. So generally topic is partitioned, and the partitions are divided into the brokers internally. Okay, but it's not equal. It's not like that every topic will be cut into parts and given to all the brokers. No. All right.
Oh, okay.
And broker in any of the servers, for example, all the broker in the cluster.
Yes,
So in any broker, we can take the information of any topic.
yes.
Okay.
Okay, you could experiment with all the four. All right. Great. So great set of questions. Moving on. So here, what we did was we created one thing I need to do again. Since I've opened a new terminal, so I'll have to set the path again. Okay, so I'm setting the path again, and then I am here. I'm going to do the consumer. Interestingly, producer needs the broker list. Okay, while consumer can consume from anywhere. Okay, a consumer need the zookeeper list. So this is the only confusion that generally have, that producer wants the broker list while consumer can do that. I'm just checking, maybe the newer versions of Kafka have fixed it. Have they fixed it? So they take, all right, all right. So new producer, broker list. It still take broker list. It doesn't take the zookeeper. All right.
But Sandeep, it should also take the zookeeper
Yes,
because the producer don't know where the broker is. Means generally
correct.
like it should also communicate through the zookeeper itself, like the consumer.
Correct. But this command, the way they have designed it is different. Ideally, it should take zookeeper just like any other commands, but it doesn't take that, and therefore we are going to find out we needed to find out about the brokers by ourselves instead of it finding out about the brokers. We had to find out. All right. So let me just cancel this. All right, because I'm going to talk on this particular topic. So we are saying Kafka consumer. This is our producer. This I've opened in one terminal, and this I've opened in another terminal. And here we are saying that from this topic, start consuming, and from the beginning. Okay, don't skip any messages. All right. All right. So on one end we have the producer. So we could say, hey. And on the other hand, we have the consumer. So the moment I type there something, this is what happened. All right. So more than one people, let's say I open one more terminal here. Let's say I open one more terminal. All right. SSH, SSH. Okay. So this is my producer. This is my producer. This is one of the consumers. And let me just open one more consumer here. And the consumer is going to be, first of all, it needs that export command. All right. And then I'm going to run the same consumer without mentioning any consumer group name. All right. Looks like it assumed that. Okay. So if I say something, will it go to both? or will it go to only one? Looks like this one is in the same group or something. It has by default assumed it to be in the same group. Okay, let me see if I could mention the group name explicitly. Oh, it's not yet connected or what? Oh, it's not connected, I think.
Sandeep, you have to change
Yes.
the localhost to the Zookeeper IP.
That's okay. That's okay. It should still work. For some reason, it's not connecting here. Maybe it's too busy. Or should I experiment with this part? I'll show you. Let's say I open a different account, right? I'll say f.cloudxlab.com. Okay, these are two different users. This is one user. This is another user, another host. All right. So let's see if we can talk to the same. We can talk to the same topic. Okay. So this is a different Sandeep at this is Sandeep at this host. You can see, and this one is Sandeep at this host. Sandeep Giri 9034. So these are two different users, different IP address. Now let me just show you if this works. Okay. Let it start. I think there's some time it's taking to connect. Now it's okay. Do you see that? Now this time it worked because earlier it was stuck in some process. So here it brought all the messages from the beginning, whatever we had produced. Okay. You can see, hey, while DD. So it has brought all the messages that we produced. Okay. While this one is on e.cloudxlab, this one is on f.cloudxlab. It's a very important exercise that we are doing. This is very important exercise.
Sandeep,
Yes.
Kafka is in big data ecosystem.
Yes. Yes. Because
So
Kafka is distributed. Yeah.
we are handling the big data. So where the big data come in Kafka? Do you mean a lot of messages when come?
Right. So when we talk about big data, right, basically all of the topic, all of the tools that we've studied are big data tools. Why? Because they are distributed. They are running on many machines. So they are capable of scaling out, and hence they are capable of handling any number of queries and any number of data. So in the classic definition of big data, you can say that Kafka is for handling the velocity.
Velocity of messages.
Yes.
Okay.
Is that what you looking for?
For example, Hive, when we use Hive is used for SQL query, and it will SQL query on the HDFS
Right.
to interpret the data.
Right.
So or to process the data. So in the same way, Kafka also interact with the HDFS.
Not really. So it is
Yeah.
not it is not part of Hadoop ecosystem, though it's a part of big data ecosystem. Hadoop is not equal to big data. Hadoop is just one solution to handle big data.
Yeah. Okay. Actually, core part is HDFS, and almost all interview question they ask for HDFS and all.
Yeah, that's basically the misconception is that it's only Hadoop which is big data. No, big data is all about distributed computing. And the core part, if you look at it, core part would be Zookeeper out of all of the big data part. All right.
Okay.
And nobody actually asks about Zookeeper.
Yeah.
Okay. Okay. Yeah.
Yeah.
If you look at the design of Zookeeper, that's the inspiration for almost all the big data tools, starting with MongoDB, Cassandra, even Hive, and even the Kafka. So all of those have been basically all of these either use Zookeeper or have been inspired by Zookeeper in the design.
So Spark is also basically used to process the data of HDFS.
Yes, not only SDFS, but you can load the data from MySQL, SQLs, anywhere.
Okay.
All right.
And Kafka is used for messaging generally.
Yes, that's right.
Okay. Thanks.
All right, great. Great set of questions. Moving ahead. Now, a question from Bhartiraja, how we will store output message into SDFS or HBase or Hive? You can write a consumer which consumes the data from Kafka and goes into the HDFS. So let me, yeah, I'll just take a look at some of the things. So one more thing I wanted to explain to you. In the big data ecosystem, we sometimes refer to as Lambda, right? Lambda architecture, right? So whatever is the data coming in from user, okay, data coming from production, data, not like this, I'll just type it, okay? So this is coming from prod, okay? So from production, whatever is the data coming in, we basically consume that, and one copy goes to, say, data lake, and other copy goes to say real-time analytics. All right. So in these kind of scenarios, what happens is that how do we handle such scenarios? So in these cases, what people do is here they set up something like Kafka, and data lake is one such consumer of Kafka, and real-time analytics is another consumer of Kafka. Okay, so that's how we use it. This could be say Spark. This could be Spark. This could be say this could be HDFS. Okay, so using Plume, we could take input from here and keep on pushing it into HDFS. So this is called Lambda architecture. All right. Great. So this is done. Now, Bidao is not able to run the consumer and producer. I'd like to take a look. Please go ahead and share your screen.
Sandeep.
Yes.
Look. So one question I have, like we just do that exercise, we have started two consumer and one producer.
Right.
But the both consumer consume the same messages. But I want like one consumer will, because there is no meaning of consuming the same message by two consumer.
Not always. Not
Yeah.
always. Let's say there are many different teams who want to be notified when user does the purchase. One is fraud team, other is email team. They will want all the purchases being done on the website, right? In that case, Vidya, just give me a second. I'll answer this and then I'll take a look. And basically, in that cases, it could be different. Now let's take a look if we can have something like let me just try this option. It's a good idea. Okay, so there should be a consumer group name. Okay, so do you see any consumer group name? Let's take a look. I'll just share my screen for time being, and then I'll come back to Pinta. So I'm just trying to look at consumer config, delete consumer offset, formatter from the beginning, max messages, new consumer, use the new consumer implementation. Okay, and how do we specify the name of the consumers? All right, probably using the consumer config, using this. Okay, so probably using this, we could implement consumer config Kafka. All right, let me just take a look if there is a consumer config that we could mention somewhere. All right, so here we could group ID. Okay, unique identity that identifies the consumer group of this. Okay, so let me just see if we could just write the name of group ID. All right, so if we have, let's say, a file here, and we just create a simple file called consumer.conf, right? And we just say put group ID is Sandeep Giri 9034. All right, and there we could say what was the consumer config, right? Where was the this one? All right. So here we could say consumer config. Okay. Also, I would like to just before I
Sandeep, please place the command of consumer and producer in chat.
sure. Okay. All right. So yes, and let me just try the same command here on this one. All right. So I'm going to say con.conf. Okay, and here we go. Group ID. What was the group ID? Anybody remembers? Equals Sandeep Giri 9034, right? Let's try the same command. All right, let it start. Okay. So warning, no broker partitions consumed by consumer. This. Okay. Should we try this now? Hey. All right. So you can see I said hey twice and both the times hey went here, but it did not come here. All right. So A, B, again, B, C, D, E, F, G, I, J, K. Let's just see, is it being divided? It's not being divided. So I see it's not coming to this one at all. Instead, everything is going to the same one. Okay. Why does it not allow me to do that? Test 5. Okay, let's just wait. All right, so good. And this one is not getting this time. All right. Probably I need a little bit more detailed the consumer config. So probably you could take a look at the consumer config a bit more. That could help us out. Okay.
So Sandeep, this is the way we can make that consumer like it can divide the
Workload.
messages.
Yes,
Yeah.
that's right. So let me just see if I could just produce some random chunk of data. Okay. Looks like for some reason it's only giving one consumer at a time. Probably we need a little bit more details about the consumer there. All right. Probably we have to specify the user ID. So it's basically switching between the two. It's not maybe when it goes over certain threshold, only then it divides the work. All right. Now let me just give you all the commands, whatever I've used. First command was this. Okay. Then this was for creating the topics and listing the topics. Okay. Then this was the mechanism I used for creating a producer. Then this was the mechanism that I used for creating the consumer. All right. And that's it. So, all right. Now, Binta, I could take a look at your screen.
Okay, sure. Okay, first, can you look at my producer? Producer is my.
Could you share your screen, please?
Okay, sure.
I had actually unshared.
Here is my screen. Here is my producer. Here I can show you my something like this.
Okay, come down. Slow. Mhm.
Okay, here.
Okay.
Okay, I can show you here.
In the small, please.
Mm-hmm.
In the small caps. Lower. Yeah, command is fine. I think command is fine. There's something else which is
Yes,
missing.
see from here. It's okay, no problem.
That's right.
I can check my topic here.
Okay, good. Okay. All right. So yes, your topic
I can
is
see test. This one.
all right. Okay, good.
Oh, there. Okay, no problem.
Yeah.
Next step, I have problem with the next step. Here, produce.
You have to find the broker list. Okay.
Yeah.
So
Okay.
try the command that I gave you in the chat. Okay. Just put your own topic name in the end.
Okay, you can see it.
Okay. So yeah, instead of localhost, just change it to the IP address that I gave you.
Okay, hold on.
Not this one. Change the broker list also. Change the broker list from localhost 6667. Can I help you in one more thing? Because this one step involves multiple things. We need to find out the brokers. So instead of this, can you launch Zookeeper client? Say Control U and Control K, Control U and Control K.
Control U and Control C, how about now?
Yeah. Okay. Yeah. Control C is even better. Okay. So you could say Zookeeper client, all small.
Okay.
Yeah. Dash. Yeah. You can press tab to autocomplete. Okay. And here you could say ls space ls space slash brokers slash IDs, brokers, not broker, slash IDs, enter. So there are 0, 1, 4. These are the identifications of your broker.
Brokers.
Slash, say 1.
1? Okay, I chose 5 before. It's okay?
Okay. Yeah, that's okay. Or maybe you can try 0 or 4. Yeah. Just take that IP address. You see plain text endpoint is plain text : / IP address. Pick that IP address.
Well, this one?
No, the IP address after //. You see host there? Host.
Here.
Yeah, this one. Yeah.
Yeah.
Yeah. Take this. And put it in a notepad or something. Okay.
Now, do I need to
just keep it in a notepad somewhere.
Yeah, I have that. Because I copied.
Yeah. It's still okay. Let's cancel it. Control D. Control V.
Okay.
Control D. Yeah. Now run the previous command that you were trying to run, Kafka brokers one. Go up. Go up. This one, right? Yeah. This one. Instead of localhost, paste the host name. Instead of localhost. Paste the host name.
Do I need to delete this one?
Port will remain same. Put the no, instead of localhost, you have to remove localhost also. colon also. Remove the colon also. Space. Yeah. Put the now at the end you have to put the port number. Internal colon.
Hold on.
Not here. Not here. Not here.
Mhm.
Not here. The broker list is there, right? The IP address that you have posted. You have to put colon.
Where?
Yeah, here. Internal colon.
Uh-huh.
6667. You see above? You see above? It has to be number. It has to be number, not P. It has to be 6667.
That's all?
Yeah, that's right. So wait for it to start.
Mm-hmm.
Just type something and press enter. Okay. So should I try consuming from here? Sorry, you can start another terminal and start consuming from there.
Consuming.
Okay.
Is that here? I did something here. Yeah, I get it here.
Okay, you get it? Awesome.
Yeah, yes,
Awesome.
here.
All right. You type more there. Type in the producer, type more.
Okay.
Okay.
Yeah.
All right. Great. You have been able to successfully establish your own producer and consumer.
Yeah.
All right.
I need to change the IP. Okay.
Okay. All right. Wonderful. And that was how we set up our own consumer and producer. All right. So this more than the Spark streaming, this is where we generally get stuck. All right, because there are multiple machines involved, multiple services involved. So generally, this is where we get stuck. All right, so we were able to start our producer and consumer. Now, I'm leaving my terminals open, so I'm going to Control C this and let my producer be there. Okay, this is my producer. Okay, and this is, let me just cancel it. Right, let it be here. Okay, so I'll just remove this consumer config. Probably I need a little bit more detailing over there. So this one is my topic. If you want to chat with me, you can actually, write on that topic. Okay, there could be multiple producers talking on the same topic. In case you're starting your own producer with the same topic as mine, then my consumer will start getting messages from you as well. Okay. All right, so that's the very simple way of communicating in the network. All right, now let's take a look at the second problem. Count the words from the messages stored in Kafka every 10 seconds. This is what we need to achieve. And for that, we are going to use this particular gist. Gist is nothing but on Git, we could copy paste our clipboard and keep it there. All right. So I'm going to take a look at this gist. All right. From here. This we have already copied, right? And we have gone to this place and here. Then we also compiled it. Okay. We need to specify the topic name in the argument. All right. So here, this is where we have to specify the topic name in the argument. All right. So this, let me just start Spark Submit class Kafka word count. And with my topic today is, what is my topic today? My topic today is test 5th May. Test 5th May. All right, here. So I'm right. So this is one consumer. So I'm going to cancel this consumer. Okay. And I'm going to go to my big data directory that I compiled last time. Okay, big data, what was the folder name? folder name is in this folder, right? So I say big data, and then I go to this folder. All right, here, and then I say this. Okay, let's see if it starts. All right, those who are wondering what is this for, what is this for? This means send all the messages to std out. I'm going to cancel this again, okay, and remove the last line, okay, because last line is all the noisy messages, all the warning messages and things, error messages, it will keep on throwing on the dev null. What is dev null? Dev null is a kind of a file in Unix, which is kind of a universal sink in which you could throw anything and it would not say a word. So dev null is to just consume, it's like an infinite sink in which you could sink in any messages. All right. So that's a device in Unix, and we are sending all the error messages in the dev null. Okay, so here you can see that it is printing the results. All right, Vinta, I just explained that part. Dev null is for sending all the messages from std out to to a sink. Dev null is a sink. Okay, now let me just say some words like this, and it should print the word count over here. All right, so let me go up. Now that's the disadvantage of not having, let me just, can I just clean it up? Okay, so if I have, let me open in Jupyter, that way I'll be able to edit my code. Okay, and all right, so where was my folder? My folder was in something like big data folder here. And here we have, say, Spark. This is my local folder, not in the repository. And I am going into, say, where am I? Let me just check my present working directory. Examples, streaming. Examples and streaming. In the streaming, you will see word count Kafka. Okay. In that, this is that Scala file. Okay. And if you take a look at the example, or let's say project here, projects, and this one, inside SRC, inside main, inside Scala. This is the other project that I'm going to show you. Okay. It takes forever to reach there. All right. Here, we could define the same log label here as well in this case. Okay, so we could just go back here. All right. Here, Spark examples, and inside these, what am I trying to do? I'm trying to modify the source code so that the log label is turned off to warning. So how am I going to do? I'm going to go into this folder, click on this, click on edit. Okay, click on edit. And here I'm going to, where is my SC? This is my, right? Okay, so I hope using, say, conf object. All right, should I try compiling if that works? Okay, I'm hoping that on the conf level, I should be able to set the. Okay. All right, so let it compile. It doesn't show us the. So how do we change the log level? Let me just see. Log level. Okay, so either we could do this way, or we could even specify. All right, should we try this one? Maybe this way it'll be all right. Okay, so going back. All right, so probably we'll have to revert the changes, and then we will. Okay. We'll just revert the changes, whatever we did. This is the change that we did. All right. Now going back and say SPT package. All right. So what we are trying to do is we are trying to, whatever we have right now here, this is the code that we are trying to run. Okay. This code, what it does is it basically, I can close this. Okay. What it tries to do is it basically opens a Spark conf object here. Then it uses the streaming context. Afterwards, it connects to Kafka just like we did. And it informs that it basically is creating the DStream that reads data from the Spark, from the Kafka stream. So this is Spark stream context object that we are passing it. And this Kafka utils is a part of Spark streaming, not Kafka. And what we are trying to do here is we are opening up DStream called lines that would read from the topic that we are passing as argument. So here, the topic that we are passing as the argument is available here. Okay, so what we are doing is whatever arguments are being passed, those we are assigning to this particular array. So first argument goes to Zookeeper quorum, second argument goes to consumer group, and third argument goes to the topic name. So, and the topic is what we are passing. So here we're passing the, in the Kafka utils, the create stream part, here we're saying that we are passing a map of the topic and the number of replication factors. So it's basically reading the data from there. And one, I think, represents the number of replication factors, replications there. Okay, and once we are done with that, then after creating a stream, we are just picking the second argument from here. Okay, I think it will be split. It will be giving out the streams per topic. Okay, so we're just picking the second one out of it. Okay, and lines is that, and then we are talking to lines and so on. All right, that's what we are trying to achieve here. All right, so we are successfully able to compile it. Let's just give it a shot if this works out, if we are able to. All right.
Sandeep, how Spark is related to Kafka?
All right. So I'll just explain. Okay. Can you turn off the phone? There's a noise coming in. All right. So I'll answer it soon. Okay. So great. Now this is the command we are executing. Question is how Kafka is related to Spark. So Spark streaming can consume data from anywhere. Kafka is just one source. Right now, Spark streaming, the project that we created, is going to talk to Kafka and be the consumer of Kafka. All right. So what it is going to do is it's going to talk to Kafka. And here, please notice that what all we are passing, this is not really required because it's not being honored. Then we are telling that this is the name of the class. This is the jar, meaning this is the bundle of code that we are passing. And this is the actual main jar file that we have our code in. Then here we are passing the zookeeper address. And then here, this is the name of zookeeper, name of the group that we are passing, and this is the name of the topic that we're passing. These three arguments are being consumed by our program. These three arguments are being consumed by this program called Kafka count, and then these are being used while creating the stream.
So
right.
Spark consumer is consuming the messages? Spark streaming consumer, I mean.
That's right.
Is consuming the messages.
That's right.
Okay.
All right. Good. So right now this is running. So I'm going to just type something again and again, and then see if it gets printed. All right. So I'm going to just take a copy of it. All right. So here we go. All right. So this is good enough. So this one next terminal should show us what's going on here. Okay. So you can see, let me go up. Did it do some computation? Where did it go? Okay, did it consume? Are you producing on different topics or something?
I am running this command.
Okay, so test 5 my. Please, if somebody is consuming my messages, please don't. Okay, so that would keep on consuming my messages, and my streaming job will never get a. Okay. Oh, it keeps on. It keeps on hanging. This terminal keeps on hanging. Yeah, it's actually computing, just that it's too fast, just too fast. Okay. Here it has done that. Can you mute Sachin? Yeah, it was doing something here. I hope nobody else is consuming messages. You can see it's basically consuming my messages and printing on the screen the word count. All right. So I hope you were able to run it. I'll just share my command with you. You need to change your topic name. Okay. And you have to go to that particular folder, the one that I was mentioning. You have to go to first CD Big Data here, and then you have to go to this folder. Then you have to clean an SBT package, and then once everything is done, then you have to execute this part. Okay. So a cleaner way could be that all of this too much of screen overflow that we were getting, we could okay, so Kafka producer. All right, so I hope, where did it go? All right, so that was about it. So okay, so that was my producer. Then using this command, I was able to consume the messages. CD big data. All right, so I hope everybody is able to do it. Should we move ahead? All right, so yes.
I have some problems, so can I share the screen?
Yes, go ahead.
Can you unshare?
Yeah.
Still, I'm not able to share.
Just a second. A question from David, before we break, was the table for Spark DataFrame versus Python was SQL? Not yet. All right.
So I did git clone, but I still not able to do this one.
What's happening here?
It's a class not found exception.
Say SBT package.
SBT package.
It's not happening. The typing is okay. Now try.
SBT package.
Okay. So it will take some time to get all the code. A question from David is, before we break, so I'll explain to you this. I want you to go. I would take you through the. I would like to take you through the streaming, and then, sorry, after streaming, we'll like to take you through the data frame. Then you'll get a fair bit of idea.
Sandeep, this is step you need to follow. These steps.
Yes. So you see, SBT clean and then SBT package. What it does is it cleans and then creates the package.
It submit the Kafka code, that is word count.
Yes. So first, SBT package builds it, and then as Spark submits it. Okay.
Okay. Spark streaming assembly, means server.
Right.
Okay, and then it will consume.
Correct.
Okay.
All right. So what we did so far is we were able to do the streaming of Kafka. So we will go over a bit of library after the break. Let's take a break for 10 minutes. All right, so let's get started. I'm back. Is everyone back? Should we start?
Sandeep, I submit the Kafka client to the Spark submit. It is
Okay.
giving the time, but it is not giving any messages
Oh, you have to type the messages, no? You have to produce messages.
from the Kafka producer.
Yes. At the same port, at the same topic, basically. Okay.
Okay.
All right. Great. Great. So yes. Wonderful. So should we start, everyone? Alvin, Alok, Bharti Raja, Pintao, David, Hitendra, Jay, Mohammed, Rajan, Raju, Robin, Sachin, Shravanti. All right, so let's get started. So what we learned so far is that we were able to consume and do the work, and we were able to do basic amount of computation. We were able to do word count. We essentially did all kinds of flat map, and then did reduce by key, and then printed. That's what we did in the code. All right. So as you saw that the DStream, the one that Spark streaming context creates for us, right, on which we were running our word count, is actually very similar to RDD. Though it's not RDD, it's very similar to RDD. So let's take a look at what all transformations and actions does it provide. So it provides you map, then flat map, then filter, and repartition, union, and count, just like RDD did. Under the hood, it's essentially a proxy. So DStream is mostly like a proxy. Whatever method you call on it, it basically delegates it on each of the RDDs which are created per time window. So similarly, it has action like reduce and count by value and reduce by key and join, just like the key value RDD. So just like key value RDD, it has count by value, reduce by key, and join. Also, it has co-group, and the extra function that you notice here is transform. What does transform do is it lets you run, it returns a DStream by applying RDD to RDD function on every RDD for the source DStream. This can be used to do arbitrary operations on DStream. Okay, so this transform function lets you execute your function on the RDD. It is just like for each of the RDD. All right, so these are the functions provided by Spark streaming on DStream. The lines object at the top that was created in our program was a DStream. It was not an RDD. So these are provided by Spark streaming. And the only special function with respect to Kafka was Kafka.utils. All right. So actually the title is wrong here. Title is wrong. This title should have been, the title is generic for almost the whole of the course. That's why it gives you an impression that it has something to do with Kafka, but it does not have anything to do with Kafka, this particular one. All right. So now, there is one function called transform, which lets you execute a function on every RDD. Okay, and this is for arbitrary operations on the RDD. Okay, so your function, whatever function you have, your function would get RDD as the argument so that you can do whatever you want on each of the RDD that will be executed. So what is the purpose of transform? Sometimes, let's say there are new functions or new features of RDD API which are not available in DStream. So transform is like a proxy. It lets you execute your own functions. This function would get RDD as the argument, and then it can do whatever it wants inside that. All right. Now, next is update state by key. Update state by key is a very important function. Update state by key is a very important function. It basically, if your DStream is a key value stream, and what you want to do is you want to accumulate the values for each of the key for this DStream, then you can use update state by key. So it returns a new state DStream where the state of for each key is updated by applying the given function on the previous state of the key. All right, it returns a new state DStream where the state for each key is updated by applying the given function on previous state of the key, and the new values for the key. This can be used to maintain arbitrary state data for each key. All right, so essentially it lets you let me give you a bit more detail. In the last hands-on, we printed the word count in the interval of 10 seconds. All right, what if we also want to count each word seen in the input data stream in last 24 hours? In such cases, how do we maintain the running count of each word in last 24 hours? To keep record or keep track of statistics, a state must be maintained while processing RDDs in the DStream. Okay, if we maintain state for key value pairs, the data may become too big to fit in the memory on one machine. Therefore, we can use the update state by key function of Spark streaming. For each key, we can retain certain value. That's what the Spark streaming provides you. All right. So the update state by key operation allows us to maintain arbitrary state while continuously updating it with the new information. To use this, we have to do two steps. Number one, define the state. The state can be any arbitrary data type. And define the state update function. Specify with the function how to update the state using the previous state and the new values from an input stream. All right. So that's what we do here. In every batch, Spark will apply the state update function for all existing keys, regardless of whether they have new data in the batch or not. All right. If the update function returns none, then key value pairs will be deleted. And right. So essentially, this can be used for maintaining a running count of each word seen in the input data stream so far. The running count is the state, and it is an integer. So here is an example of the same. All right. So we could use this kind of a function. So we will have to define a function called update function. First of all, this update function will get two things: new values and running count. All right, new values, and this is the existing value. And these are new values, whatever are happening for each key. And this is the running count. This is the old value for each key. So how to update particular values for a key, specifically when we are accumulating the values for each key, that's where the update function will be used when we call it on updateStateByKey. Okay, so we define some function here such that the running count plus equals to running count plus equals to new count. Okay, running count plus equals new count, and that's when it'll be called. Okay, that's when it'll be called. Like here, similarly, if you are coming from Python background, this is how it'll look like. So these are the new values, these are the old values. If the old values are none, that means this is the first time the update is being applied, and we are saying running count equals 0. Okay, and here we are returning sum, which is sum of the new values and the running count. Okay, so this is the new value, this was the existing value, these were the values that came in for each of the key. So essentially it is kind of maintaining a dictionary internally. The only control it is giving us is manipulating the update function. It is not giving us the handle to the dictionary. All right, so this way you could maintain the statistics of each key in a key value DStream. All right, so you could take a look at the examples of DStream here. Okay, so all right, so another function called transform allows arbitrary RDD to RDD function to be applied on DStreams. Apply an RDD function that is not available in DStream API. It's perfect for reusing any RDD to RD function that you may have written in the batch code and you want to port over to the DStream. It's a very handy function. Let's say you were writing a batch program that you were manually executing, and you had written this function which operates on an RDD. So all you have to do is you have to change the function such that that function takes the RDD as the argument, and then you can use that using transform. Right? Say, for example, the functionality of joining every batch in the data stream with another data stream is not exposed directly in the DStream API. So all right. So you can see here, all right. So we can also say join the data of a DStream with an RDD using say transform. Here we are passing the RDD to our function. This is the function that we have created here, the inline function, and we are saying RDD.join spam info RDD. This was our one of the RDDs. Okay, so using Spark context, we created some RDD and we're joining the current RDD which are created as part of the Spark streaming with that RDD. So this is essentially, so in such cases, you should cache this RDD because you are going to join it again and again. And the important part is that transform is calling your function on top of the RDD. This part is going to be called every time an RDD is created for a time window. All right, so you can take a look at the transform operation in detail there. All right, now there is another idea. So we talked about how to connect to the network stream. We talked about how to connect to the Kafka stream. Also, we talked about the various functions that are provided on top of DStream. And even if you don't know much functions on the DStream, what you can do is you can use the transform and use any function from the RDD API. All right, and using the transform, as well as we talked about update key. In case you want to aggregate or accumulate summary, then you can use updateStateByKey. And here, what we were talking about is how does this work? Here, we basically load the data from Hadoop using this API. There is a Hadoop format called sequence file format. That data you can load using this API. All right, and now The next thing that Spark Streaming API provides to you is window operation. All right, let's say you want to operate on multiple time windows. You have created 10 seconds window. Now you want another bigger window, say on 50 seconds, and so on. So on top of this, you could create the window operations on any streaming, any RDD. All right. So use case could be in monitoring the web server log, find out what happened in last 1 hour, not house, last 1 hour. Okay. And let's say what you want to do is you want to find out what happened in last 1 hour and refresh that statistics every minute. So what we do is in such cases, what we do is we create the window of length 1 hour and slide interval as 1 minute. So this way we have the data of last 1 hour continuously updated every 1 minute. So the window is sliding by 1 minute and the window length is 1 hour. So this is what it depicts. So the window based operation could slide here. It's, let's say it's sliding by, this is say 3 minutes window and it is sliding by two minutes. Okay, so this is what happens. This is original DStream in which there are so many time windows. For every 1 second, we have created RDD under the hood, and window DStream is nothing but combining them multiple into a single window, right? And keep on moving this window operation, right? So we need to specify 2 parameters. One is window length, other is the duration of the window, 3 in this example, and so basically, we need to specify 2 parameters while creating the window. One is window length, other is the sliding interval. These 2 parameters must be multiples of batch interval of the source DStream, right? Because the minimum unit of the time is the unit in which the DStream was created. All right, let's take a look at reduce key by right. So here this is one example where what we are doing is we are computing the count of words in 30 seconds of input data every 10 seconds. Every 10 seconds, this is going to print the result of the words in last 30 seconds. Okay, so there's a 20 seconds of overlap. So all we are doing here is we are saying pairs.reduce by key and the window. And here we are providing 30 and 10 as the argument. Also, please note that pairs is a key value DStream. Okay, you could take a look at
I
the
have a
window.
question.
Yes, go ahead.
In the previous slide, can you go back to the previous slide?
Okay, let's go back. This one?
Yeah, no, the next one, the code.
Okay.
So this will not take care of the state, right? So this will not give you the running count again. It will only give you the word count for that particular window.
Yes, for that particular window, it will do that.
So it will not give you like a continuous count. Only in that particular window, whatever is the word count, it will display that.
Correct. It won't give us so far. It won't go so far everything.
Only for 10 seconds.
That's right.
So you have to integrate updateStateByKey over here to integrate that feature as well.
Correct.
All right, thank you.
A question from Binta is reduced by key and window a transformation and only for Kafka? No, it is for the Spark streaming in general. All these operations after our hands-on are generic to the whole Spark streaming. Okay, after the break, whatever we have talked about is generic to all Spark streaming. All right. Now, the Spark streaming, the DStream that we created provides you all kinds of operations, such as you can join 2 DStreams. Let's say there is one DStream that is on a time window of 1 hour. Then there is another DStream that's on a time window of say 20 minutes. We can join these two DStreams and we can get the results. So here, right here is each interval. In each interval, the RDD generated by stream 1 will be joined with the RDD generated by stream 2. Okay.
So D stream is nothing but a stream of data, correct?
DStream is what is the basic, like we had RDD in case of Spark context, right? Now Spark streaming context gives us the DStream. The line and everything in our case, if we take a look at, I'll just show you this code and then you'll get an idea. Okay. Where did it go? All right, let it come. Can you hear me? Hello?
I can. Yeah,
Okay.
I can hear.
Could you give me a second? I would like to switch the internet connection.
Sure.
Okay, it'll just take a minute. All right, are you able to hear me now?
Yeah.
Great, great. I've switched the internet connection to a faster one. That was one of the reasons why I was getting delayed. Now, so here, if you take a look at this folder, inside it, the Spark folder and then the streaming folder, Spark and examples. And here we have the streaming. So in the streaming folder, what you see is word count Kafka. All right, and let's take a look at this one. So you see here SSC is Spark streaming context. This is the entry point, and lines is a D stream. Same is the case with words and pairs. In normal programs, these objects that we created by map, flat map, and other transformations in action, those were the objects of RDD. But here, these are the objects of DStream. Okay. I hope you got the idea.
But how are they different? I find them very similar to each other.
Correct. They are very similar to each other. The only difference is these lines, right? Lines is basically a D stream, which is nothing but when we run the program, it's going to create RDDs under the hood. So whatever function like flat map we are defining here, then flat map will call flat map on every RDD that gets created in that duration. So here it's happening on 1 second. What is the time duration? We are creating the stream and
2 seconds.
Here, 2 seconds, right here. So every 2 seconds, RDD will be created under the hood, and this function like flat map will be called in that RDD. Okay.
Okay.
That's what it is going to do.
So in the context of Spark streaming, it's DStreams, while in the regular context, it's RDD.
That's correct. That's correct.
Right. Thanks.
Okay. It is essentially creating every 2 seconds, creating that RDD and executing whatever we have specified in the graph. That's the advantage of creating graph.
Big data is Scala. The code, where is the code is?
Code is Scala. Code is in this folder called Spark. Inside big data, Spark, then examples.
Okay. Yeah.
Okay.
Got it.
All right. So.
Sandeep.
Yes.
I had one question like related to Kafka.
Mm-hmm.
So just when we start the producer and putting the message into the topic,
yes,
is there any command like we can see the messages in the topic? Like
Mm-hmm.
these are the messages there in the topic.
Mm-hmm.
So is there any way to see the message in the topic? Like,
Yeah, that consumer does it, no?
no, I don't want to start consumer. I just want to see our message is going into the topic,
Mm-hmm.
and I can just list down that, and I can see that. Like,
Okay.
is
So
there?
see, if you are worried that when you start consuming, then other consumers won't get it, don't worry about it. Because since if you don't specify the same group name, it's going to broadcast to all the consumers. So
No, I just want to, without using consumer, I just want to see the message in the topic. Is there
okay.
any command
So
or?
just take a look at the folder, probably just browse through that folder as well as go through that consumer shell script.
Okay,
Okay. Does it give you a count alone and not? Okay.
okay, 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 sir.
So,
All right.
Sandeep, all the big data code is in the big data folder.
That's right.
Okay, thank you.
A question from Bintao is, do they join parallelly or they append? They join based on the key. These join operations are valid for the DStreams, which are the key value pairs. All right. So we can also do left outer join, right outer join, full outer join, just like RDDs. Similarly, so we have RDD, we have DStreams, and we have windowed DStreams. Okay, so window DStream also provide us joining amongst each other. Each window DStream could have multiple DStreams, and so essentially, window DStream could be operating on multiple RDD at one point. Okay, so essentially there are three things that we operate upon. One is window DStream, and RDD. RDD is our usual batch-wise process. And DStream is nothing but a representation of time window and multiple DStreams combined together is one window. Okay.
Can you
So
give
this
an
way,
example of the join operation
join operation on DStream or
on these teams?
on DStream. So join stream as in, let's say you are having two different data sources. One is Kafka and other is coming from somewhere else. Let's say on your website, some operations are happening and the data is coming from both the sides. And what you want to do is you want to continuously correlate the data from the production as well as from the other streams such as our logs from so let's say one stream of data is coming from, say, we call that AWS logs. The can you mute, sorry, Mohammed? And okay, so let's say there are two streams of data. One stream is coming from, say, AWS, and other stream is coming from our website server logs. And both of these streams, we want to continuously merge and display to the end user or to for some operations intelligence people who want to observe the operation. In those cases, we would like to have two DStreams, one consuming data from AWS, other consuming data from say our Apache logs, and then joining the two DStreams and combining them together and giving the results. So that
But
could be one such example.
the thing that like I have a doubt on is like what is the join condition?
Right. So good question. So the join condition is these are key value pairs. Okay, these are equijoins. Equijoins as in let's say I'll just show you. So just like our RDD joins, okay. So just like our RDD joins. So imagine that we have, let's say, this is one RDD. This is one DStream. This is another DStream. Okay, and this one has one key called SG, and the value is 10. And this one is having another key called SG, and the value is 20. Okay, then we have Muhammad, and let's say 12, and here there is let's say Alvin, right? And this is 15. So when we are joining these two together, when we are joining this, when we say this RDD, this DStream join with this one, then what we get is essentially SG is the key, and the value is a tuple of 10, 20. This is what we get. All right?
Got it. Okay, so it's implicitly on the key.
Yes, it is implicitly on the key.
All right, thank you.
Good question. So moving ahead, so we can do the join operations just like RDD on DStreams. And so here at each interval, the RDD generated by the stream 1 will be joined with the RDD generated by stream 2. We can do the same thing like left, right, or outer, full. We can do that. Okay. All right. Binta was able to answer your question. I think you had the same question. All right. So we can also do a window DStream or window stream also provide us a transform function just like normal DStreams provide. All right. You can take a look at more join operations at this manual. Okay, great. Now, so the output operations allow DStreams data. So on DStreams, other than these window operations, key value operations, and the usual operations, there are some more operations that DStreams provide. Some of them are output operations. We used the pprint or print operation earlier that was outputting the results. So DStreams data can be pushed out to external systems like a database or a file system. And since the output operations actually allow the transformed data to be consumed by external system, okay, they trigger the actual execution of all the DStream operations similar to RDDs. Okay, a question from Binta is, where does the function of window come from and how does it work? So yeah, so the window operation, this is what I was talking about. So on a DStream, on a given DStream, we can create windows such that multiple time windows of a DStream will get combined. Imagine that you have a DStream which is being executed at every 1 second. And what you want to do is you want to combine 3 seconds data and process that. And you want to slide it every 2 seconds. Okay. So that in those cases, we could use the window operation.
I have a question on this. So what would be a good data set wherein the data is coming in continuously and then you're processing on the fly? So like real-time analytics, but the data set is coming continuously. It's not saved anywhere. So which data set would you use in that operation?
Oh, there are many data sets, right? Basically, anywhere you want to do operational intelligence, you would like to continuously monitor as opposed to somebody refreshing it or somebody executing a command.
So like if I were to look for something online, which data set should I use to perform stream?
For stream processing, I think but the best one is to use, say, Twitter or something. Twitter gives you a good stream of data that you can operate upon.
Any other except for Twitter?
Any other, you can actually consume the data from HDFS itself. Okay. HDFS itself, keep on putting the data in a folder, and it'll be consumed as it will be every time you upload a file, it'll be loaded in the DStream as a new data.
Okay.
Okay.
Okay. So continuously keep appending data to HDFS.
Right. Or let's say your system file. On your computer, there's a system log file. Every now and then it's generating data. You can use that one. Okay.
Okay, thank you.
All right. There is a way to even talk to the syslog daemon. Syslog daemon on your Unix machine, it generally runs on a particular port, and you can make Spark streaming talk to your system log, and it will continuously absorb the system messages, and you can perform the analytics on that. All right.
All right. So it's like a continuous flow of data.
Yeah. Or let's say you have a web server, the logs are being generated every time somebody hits. Like, for example, I'll give you a very good example where we use real-time analytics. One of the very good use case that we did at Amazon. In case of Amazon, we have like e-commerce website, and we cannot afford to take a risk of shutting it down or anything happening to it. So what we were doing is we were continuously monitoring around hundreds of our servers parallelly, and we were basically fetching all the logs and bringing it to a central system and combining it, grouping the data based on the error message. So if a certain error message is coming beyond the critical numbers, then we suddenly, it used to trigger an alarm and send an email to the people who have made the last changes in that particular branch of code. Okay, so those were the real use cases of real-time analytics. All right.
So grouping by the same type of errors, you mean, right?
Yes.
Or the same type of warnings.
Yes.
And then opening a ticket so the relevant team can act upon it.
Correct.
Thank you.
All right. So that's again operational intelligence that we did a lot at Amazon. And all right, so moving ahead, and yeah, so we talked about join operations. So we were talking about the output operations. So just like we had take or save as or some other operation, we also have the output operations on DStream, which such that we can store the data on external systems like a database or a file system. Since the output operations actually allow the transformed data to be consumed by external system, right? So they trigger an actual execution, just like any collect, take, or save as text file or save as files. All of that on Oddity triggered the whole execution. In the same way, DStream also trigger the operations execution of all. Right. Next is the print. Print prints the first 10 elements of every batch of data in DStream on the driver node, running the streaming application. This is useful. This we have already used. Print was printing every time, on every window. When we call print, it was printing the whole results. And this is only good for development. In the real time, we will like to use a save as text file. So every time we call it save as text file, the DStream, for every time window, DStream is going to create an Oddity. On that Oddity, save as text file will be called. So save as text file will create many files in the folder because it is happening on every time window. So we'll have prefix and suffix. So we can provide the prefix of these files as well as suffix if we want. And it'll also put time in the milliseconds as the file name after the prefix and before the suffix. All right, sometimes we may want to, instead of saving as text file, we may want to save them as object files. So we can save the oddities as sequence files. Sequence files is a format of Hadoop in which you can save the objects as save the file, let's say save the oddity containing objects into a file in HDFS, and while loading you only have to provide the data types of key and the value, and it'll load that data. So sequence files or object files are essentially the key and value kind of a format. It contains many key and value. Key could be binary, value could be binary. Okay. And sequence file could be in gigabytes or terabytes. Now, the next thing is save as Hadoop files, right? Now, for each RDD, we could call a function. So for each RDD, that function is basically an action, and that allows us to execute any function of the RDD. All right. So just like for each on RDD, we were calling for each function. In the same way, we could call for each RDD, and it will execute your function on the RDD. Okay, so this function should push the data in each RDD to external systems, such as saving the data to files or writing it over to the network. Note that the function is executed on driver node running the streaming application. Okay, this is a little dangerous one, because this function is going to bring the RDD and then bring the RDD locally and operate on it. Okay. So it allows the data to be sent to external systems. Often writing data to external system requires creating a connection object. So TCP connection to a remote server and using it to send the data to a remote server. So we can use this to take the entire RDD and push it somewhere. A developer may try creating a connection object in Spark driver and then try to use it in Spark worker to push the data in RDDs to remote system. So here I'll just show you the design faults. So let's say take a look at this one. Here what we are doing is there is a DStream. There's a DStream, and in the DStream we are calling for each RDD. Right? Here we are creating a connection, and then for each connection, then please notice that on the RDD we are calling the for each, and there we are passing the same connection. Right? Now this connection will be executed at a worker while the connection was created on the driver. Right? This is completely wrong. This is dangerous, and you can't really send a connection object to the worker. The right way is that in the for each itself, in the for each on RDD, we create a new connection and then operate on that, instead of creating connection on the driver and then sending it to the worker. No, this is something that wouldn't work. Instead, inside the RDD.forEach, you create a connection, use it, and close it. Okay. Now design 3 is this.
I little understand what is the difference between RDD and DStream.
Okay. So what is a DStream?
DStream is streaming, taking the streaming of data. It's taking the, yeah.
Okay. So see, whatever functions we are defining on DStreams, right? We are under the hood, those functions will be called every second on the RDD. So DStream we are defining right now. So DStream essentially is going to create RDDs every time period. Okay. So Spark had RDDs.
You mean RD instance it will create?
Yes.
Okay.
Okay. So Spark had RDDs, and DStream guys, what they did was they wrote a big for loop. In that big for loop, they started consuming data every time window. And then in every time window, they kept on creating sc.parallelize and give that data. So periodically, every 10 seconds or every 1 second, whatever you want, at every epoch or every time unit, it would create an RDD under the hood. So that's the difference between these streams.
So for the stream of data, we are applying a RDD. for transformation as well as output.
Right.
Okay, correct. Thanks.
All right. So DStream.forEach RDD, what it is going to do is whatever function you give to it, it's going to execute that on every RDD. Okay. So there are three design we talked about. Design number one, design one, in which connection was created inside the for each function, and then inside the for each RDD function, and then was handed over to the for each function. Second design was that connection was created inside RDD.forEach. Third design was that on the RDD, we called RDD.forEach partition. And there we created a new connection, saved the results, and closed it. Now, in your opinion, and that there's a design for that on each partition, okay? All right, so what is it that we are trying to do? Okay, let me start from here. Let's say our purpose is that we are done processing DStream, okay? And at the end of it, we would like to push the data to a database, right? How do you push the data to database? You create a connection, open the connection, save the results, and close the connection, right? Connection is basically to a database server, all right? So one design is that inside the for each RDD function, we are creating a connection, and then inside for RDD.forEach, this logic will be running on the worker node. Please keep in mind. All right. So this one will not work out because this is going to happen on some other machine. This is going to happen on some other machine. Now the second design was that do it for each here, RDD.forEach again. So when we say for each, inside every function, we are creating a connection and sending the data.
So the design two will like open the connection, close the connection, open the connection, close the connection.
Right.
Over and over
So,
again.
yeah, design one will create a connection one time,
Only once.
but we are trying to use it everywhere. But since this could be on a different machine, therefore, connection object is not supposed to be handed over to other machines.
Okay. So the
Okay.
design one is not right. Design two is a lot of IO.
Yes, design one is not right. Design two will basically for every record, it is creating a connection. So there are too many connections in two, and there are too few connections in one, right? Therefore, this one will work, but it will basically create just too many connections for every record. It's doing that. Okay. Okay, a question from Raju is, in case we are creating connection for each RDD, that's right. In case two, we are creating the connection for each record of RDD, that's right. So neither of the approaches are right. Okay. Now, third question, a question from David is, if the connection fails, how is the failure handled? How is the failure handled? Now, this is an interesting question. So if the connection fails, how is the failure handled? Okay. As in, so if let's say we are creating a connection here and something goes wrong here, so it's difficult to handle that failure. The only way we could do is we can say that, okay, if connection not found, put it in the output, and in the next go we will approach it again. Okay, so approach it again, try opening it again. So we can basically create multi-stage saving, in which first stage it'll create like say output, and then using the filter we'll remove all the records which have been saved successfully. In the next go we'll try again. Okay, so that's kind of a retry pattern, and it would be an interesting exercise to try to re-implement it. Okay, so essentially what we do is here, while trying to save it, we'll basically return, instead of calling on for each, we'll then use the map RDD. Okay, very good question. So,
or is there a try catch over here?
even if there is a try catch, what we will do there, even then we can just display the error, right? We have to, if we want to track that these records were successfully saved, these were not successfully saved, in that case, we could just use map RDD and retain those values.
But if
Okay,
there is a try catch, then I would know like where exactly did the connection fail.
right.
So from that point on, I can copy the records. Otherwise, it's going to be too much duplication again.
Correct, correct. That's exactly, or maybe using a filter one. Okay, if successfully saved, then return false. If failed, then return true. That means the failed record will be retained. Okay, good question. A question from Binta: is DStream a data type and only for Spark streaming? That's correct, Binta. DStream is a data type and only for Spark streaming. Okay, DStream, Windows Stream, both are data types and only for Spark streaming. All right, so design 3 is that we are going to create connection per partition. Now, since one partition does not go beyond one machine, therefore, it is completely safe to create partition per partition connection. All right, and
Sandeep,
here,
actually, my internet was connected. I have one question. Each DStream and RDD have a different data when the data is split out. So how the failure, will they maintain a copy of it?
what?
Each stream of data are processing a different data.
Right,
Yeah. So for example, if you have a big log file, it will break.
right,
It will break, and each DStream and RDD has contained different data.
correct,
So they have to be at the end, they have to give a single result.
right.
So if the failure happens, then how that data can be recovered?
Right. So those are the design choices that you have to make. Okay. So, so there are two things we are talking about here. In case, let's say we are doing the usual processing and one particular RDD fails to process or access, that RDD can be reconstructed and used. Okay. That is something that Spark does for us. Okay. That is one thing that we talked earlier, whereby if let's say one RDD fails, some way like the machine on which RDD was running has gone kaput, and we can recreate that. It will automatically recreate the RDD and run it somewhere else, right? Here, what we're talking about, while saving the data, if the connection fails, what are we going to do about it, right? So that's a hard, interesting question. What we can do is, instead of using for each RDD, we could use filter RDD. Okay, what it does is that it'll take the function from us, and it'll execute that on every RDD. And in there, what we can do is, in case saving failed, return true means retain the data. Otherwise, return false, meaning it has been consumed if saving was successful. All right, that's what we're talking about, the failure. Okay, a question from Binta is, can you show how these data types can be created? So yeah, DStream we have created already. Okay, DStream we created already, like here. When we were talking about our, say, this code, DStream we created here. This is DStream, okay? As well as when we were using, say, other one, not this one, okay? Let me just show you. Okay. So this was our Spark streaming context, and this is a DStream. So this is one DStream, this is another DStream. Okay. So this is how we created the DStream, and RDD we have already created. Is that your question, Binta? And when we operate on DStream, like lines.flatmap, this one is again a DStream. When you operate on words.map, this is again a DStream, and so on. So a transformation on a DStream returns a DStream. Transformation on RDD returns an RDD. All right. All right. So yeah, we were talking about this. So here the connection was creating per partition. Now we could go further one step ahead and use something called connection pool. What's a connection pool? So what connection pool is like an object pool that use the object and return to the pool instead of destroying it. Okay. So instead of creating a fresh connection every time you want it, what we do generally is we create a few number of connections, keep it ready, keep it open, and keep on reusing the connections between various calls. So that here there is no time consumed in making the connection. All right. So once you're done, you return the connection instead of closing it.
Can you elaborate on this approach like design for?
Yeah, design 4 is the right design to follow. So wherever, let's say you are building a website or anywhere you use a database connection, what you generally do is you create the object of the connection, which is nothing but connections. So we keep these ready because it takes around few milliseconds to just create a new connection to the database, because it requires opening the port, connecting to the port, and so on and so forth, right? There has to be a handshake and so on. So instead of every time we need it, we will just create, instead of that approach of creating new connection every time, what we do is when our application boots up, it creates fixed set of connections, or maybe it's lazy. When we call the get connection only, then it creates, and then it keeps it. Instead of destroying it, we are reusing it. All right. So that's the approach.
So
And this
different
is
connections.
yeah.
Different connections on different port numbers, right?
No. So on one server port, many clients can connect, right?
Yeah, correct.
So it'll be the same port.
Okay, same port and different connection objects.
Right. All right. So if multiple partitions are there on one single machine, then one single connection is going to be used instead of creating a connection again and again. All right. This is the advantage of this approach. So that was the, you can learn more about the output operations on DStream here in the API. API is the right way to learn about Spark. All right. Next is, this we have already finished. All right. So that's pretty much with respect to the DStreams and the operation on the DStreams. All right. So yeah, I think that everything has been taken care. I'll just put a thank you slide here so that there is no confusion. I'll just put a thank you slide here. Just after, no, this one is old. All of this is no
So
longer
Sandeep,
valid.
Spark streaming can take the data from HDFS also.
Spark streaming can, yes, of course. I'll just show you that part. Spark streaming. Okay. So yeah. So if you take a look at, let's say, this API here, okay. So there are many functions such as right. So you can open the Here, this we have talked about. Okay, so this we have talked about. All right. So there is a API. I want to just go through the API docs. Okay, so we could say Spark, no, DStream, or Spark streaming context. Okay, this is that streaming context. So streaming context lets you open all kinds of connection. You can open the socket connection. This is the one that we used earlier. Then we can also, let's say there is a folder here, the directory in HDFS in which you want to over which you want to create a Spark streaming. Then you can use the text file stream, so that whenever you're creating a new, whenever you are let's say there is a folder which you want to monitor, and as soon as somebody is putting the file in that, you could use the text file list. You could just load the new file and process it. That's what is the text file stream. Okay, so you could take a look at this one. All right, so yeah, so that was the usual streaming operations. Now I would like to continue with the data frames. All right, so I'll just go over the data frames quickly, and because data frames is a good topic and big topic. All right, so what we learned so far is the part where we were not knowing how would the record look like internally, right? So whether we process the DStream or RDD, every record was an object, correct? We did not expect any, at most we had key value RDDs where we knew that the record contains key and a value, but nothing more than that, right? But if you think about SQL or Microsoft SQL or MySQL, every record is supposed to have same fixed number of columns, right? Every record is supposed to have same fixed number of columns. There are many advantages of that. You could have very flexible query options such as group by and so on, right? Therefore there was a need to create a similar structure in Spark. So Spark SQL or data frames is a Spark's module for structured data processing. Let me just share this slides with all of you. All right. Great. So Spark SQL is a very powerful module. It's great for structured data. What is structured data? Structured data is nothing but data in which we know the columns, and all the columns must have the same data type. As in, all the rows for the same column will have the same data type in that particular column, although different columns could be of different data type. So Spark SQL is very well integrated with the is very well integrated with SQL queries and Spark programs. So Spark SQL lets you talk with the same lingo as we talked with RDD, as well as it lets you talk to the data using SQL. So you can read the data from HDFS, Hive, relational databases, Avro. Avro is another format. We'll talk about these formats. Avro, Parquet, ORC, JSON, and you can even join data across these sources. So Spark SQL not only provides you this data frame which you can operate with SQL and usual program, you can also load the data frame from different data source, from different data formats, and join them together to get the desired output. This makes Spark SQL super powerful in handling all kinds of structured data. So in industry, this is one of the biggest problems that people face. Some of the data is lying in HDFS, some of the data is lying on AWS, some of the data is lying in MySQL, some of the data is lying in Kafka, and so on and so forth. And in this way, you don't generally get to join that data. You don't generally get to concatenate that data. And this is where the Spark SQL is very powerful. A question from Middaw: could we practice some typical regular expression to extract some? That won't be here, but we can, if you are confused about regex, we can have a separate session. All right? Or you could just post on the forum. I would love to answer. All right? So here, let's talk about the difference between RDD and data frames. This is an important part. This will clear your comparisons between SQL and data frames, the one that Bintao and David has asked earlier. So yes, Sachin, just stay tuned. That's what I'm defining. So a data frame is something that has columns and that has columns, while RDD has only record. This was an RDD. When we said lines equals to sc.text file, what it did was it loaded the entire line in a record. So each record is seen in RDD as something unknown. Okay, while in case of data frames, we have columns. Okay, so data frame is nothing but under the hood, it's an RDD, but data frame have columns. Now you can compare. So data frame have columns, meaning data frames are great for processing structured data where we know the columns, we know their data types. And RDDs are great for processing unstructured data where we don't know the columns and we don't know their data types. The RDD has, you can see here, it has record as the smallest unit. Here it has the cell value as the smallest unit. So it is unstructured, and we need, every time we want to process something, we need to write map, reduce, or for each, or flat map, or filter, right? Here on the right hand side, since the data is structured, we could use SQL kind of syntax on data frame, such as we could say select ID where name equals Priya from this one, or we could say arc-like syntax. This supports R-like syntax, by the way. It supports both. Spark SQL provides a data frame which you can create from RDD or from any kind of sources on which you could run SQL query, as well as you could do the R-like syntax. Those who are coming from R background or SQL background, they'll find at home with the data frame. Okay, could we practice the different database with Spark SQL? Yes, we'll do that. We'll connect to Hive, we'll connect to MySQL, and then see. All right, so data frames have column 1, column 2 like this. And data frames have columns, and they under the hood, a data frame is an RDD whereby we have extra information about the columns. Okay, and when we say partition, every row is not broken. Okay, so some of the rows are in one partition, some of the rows are in another. So it's a collection with the named columns. It's distributed. It's same as database table, a data frame in R or Python. So data frames can be constructed from structured data like CSV or JSON. It is the semi-structured data, or Hive, the proper structured data, RDBMS, proper structured data, as well as the unstructured data like RDD. So we could create the data frame from any of these sources. Also, the data frame API to do run SQL, to run the code, to run R-like syntax could be done using Scala, Python, R, as well as Java. Okay, so please note that it's an important part. The Spark SQL is the biggest change that has happened to Spark after Spark 1. Therefore, we will be using Spark 2, specifically the 2.2.1. That's the latest version, using the usual interfaces like Spark Shell, Spark Application, PySpark, Java, etc. So remaining the interaction would remain the same. There are only very tiny differences between Spark 2 and Spark 1. Those we'll discuss now. To get started, we need to export these two variables, Hadoop conf directory and yarn conf directory. All right, and there are quite a few versions there. And this is the version that we are going to use, although we can use the latest version as well, 2.2.1, but that's completely same. Okay, so those are the identical things. All right, so let's take a look at this. So we are exporting Hadoop conf directory. This is how Spark comes to know about our Hadoop installation. Okay, it goes to the directory, it looks at the configuration file, and it finds out about our name node, our HDFS, as well as it finds out about our yarn and everything from that folder. Okay, so we are going to connect to, let's say, my account using SSH. All right, we have exported this variable. I'm giving you one copy, as well as, okay, here is the one. Then here we are saying ls/user. Now, we could either use this or any of these versions. We could use this version as well. We could use this version as well. This is the latest version. So we could try to both. Okay, I'm just replicating both of these so that we have both of these versions. All right, so let's take a look if it is working fine. All right, so we could use either this or this. All right. Why it's taking so much time? All right, so when we are using Spark 2 specifically, there's a tiny difference between the two. Okay, one difference is the SC, along with SC, we are also given Spark. In the future, this is going to be our entry point. Okay, this is going to be our entry point. This is something that is going to be for backward compatibility. Okay, so when we say Spark context, okay, Spark context is equal to the SC. Okay, SC and Spark.Spark context are equal. All right, and to access the SQL context, we generally have this object. Okay, using this, we will be interacting with the Spark SQL while using Spark context or SC. We will be using the RDDs. Okay, so let's get started. So this is one difference between Spark 2 and Spark 1, that Spark 2 is designed for Spark SQL. From the usability perspective, there is an extra variable called Spark. This Spark is the main gateway that's going to be the main gateway in future. and you will access everything via Spark object. Okay, if you are using, say, build mechanism where you will do Spark submit, you can create your own object using this kind of system, whereby you will say Spark session. First, you will import a Spark session. Okay, you will import a Spark session. Okay, and then you will say Spark session dot builder. Okay, here I'll have to convert this into a single line. So we'll first use the builder, then set the app name, set the config, whatever config we want to set, and then we'll say get or create. Okay, so this way we can create our own Spark Spark entry point. The one that we use in Spark Shell is created using this kind of mechanism. All right. So this is also for many cases, we may want to use the implicit conversions available from a Scala, available from Spark to be hooked at various points. So we may want to import the implicits. We may want to import the implicits at various points. All right. So that's our way to get started, and you could give it a shot. And okay, after these two, I'm just going to give you this command. All right. So yes, if you are trying to build an application, just keep a note of this particular format. Rest of the things will remain exactly same. So if we are creating a Spark submit, a program that will be submitted, what we have to do is we have to create a main program. There'll be a main method. Inside the main method, we will have this object created Spark, and remaining program will be operating on the Spark. Okay. Now let's get started with processing some data. Let's first of all take a look at this file, people.json. Okay, I'm going to open another terminal so that I don't have to close my Scala prompt. Okay. All right, let's just get started and then we can take a break. All right, so here, so we have, say, people.json. This people.json is located in HDFS. You can take a look at it from Hue from file browser. You'll see that every line is a valid JSON object. You see, it has key and value. It's not an array, it's an object. Second, please note that this whole thing is not a single object. Every line is a valid object. Okay, so now using such kind of JSON file, we can simply create the data frame. We can simply create the data frame. All right, we could simply say spark.read. Okay, so here we are saying Spark, that's the entry point we are talking about, spark.read.json, and we are specifying the file name from HDFS. Okay, now here, all right, why does it, okay. So I'll have to exit from here. I'll go back. Okay, I think let's go back to the previous version that we'll stick with. Let's just stay with this version. I think there will be differences. All right, let me just go back to. All right, so let me just get started. So here, this is our JSON file. We are trying to load it as a data frame, like a table, so that we can operate on it without writing the code. Okay. So if we have JSON in the form of this way, where each line is a valid JSON object, then we can load it in the data frame. Okay, let it load. All right, I'll try to open the Spark UI. All right, so let's go back here and try to load the data. Here we go, and take a look at it. So, all right. So it's talking to the HDFS and loading the data. It's trying to, what it's trying to do is it's talking to HDFS, trying to figure out the format of this file and creating the data frame based on the format. It's bringing the names of the column by sampling the input, and then it is going to give us those columns. All right. So here,
Spark.json is a function which will create a data frame object.
yes. So this function loaded the JSON file. Okay.
Yeah.
And you can see that it has created the table. Okay. All right. We will continue from here tomorrow. All right. We will continue from here tomorrow. Thank you, everyone. I look forward to see you tomorrow. Bye-bye. Thank you, everyone. Thank you, Alvin, Alok, Bharti Raja, Biddao, David, Hitendra, Jay, Mohammad, Saruk, Mohammad Rajan, Raju, Robin, and Sachin and Shravanti. Bye-bye. Have a good day.